Hi everyone! We are from Group 3 and we will be presenting about redox titration today.
Reduction oxidation titration, is known as redox titration, is a fundamental analytical chemistry technique used to quantify the concentration of a specific substance in a sample. It plays a crucial role in various fields, including chemistry, environmental science, pharmaceutical, and industrial processes. Redox titration is essential for determining the safety and efficiency of products, ensuring the quality of pharmaceutical and food products, and maintaining ecological balance. It is particularly useful when it is challenging to directly measure the concentration of an analyte using physical or chemical properties. Advancements in analytical instrumentation, automation, and data processing have improved the precision and efficiency of redox titration methods. Future prospects include the integration of robotics and artificial intelligence.
Before looking further into the experiment, let me explain about the types of redox titration. There are 5 types of redox titration. Firstly, permanganometry titration. This titration uses potassium permanganate as their oxidizing agent. Potassium permanganate do not require any indicator as it has the ability to change the analyte's color into purplish pink. Secondly, dichromatometry titration. This titration uses chromate as the oxidizing agent. The chromate ion reduced into C3 plus ions during this titration. Thirdly is the iodometry or iodimetry titration. Iodimetry is a direct titration, meanwhile iodometry is an indirect titration. Both uses iodine as the oxidizing agent. However, iodimetry uses neutral conditions. Next, bromatometry titration. In this titration, potassium bromate is used as the oxidizing agent. During the endpoint of the titration, the analyte changes into pale yellow. Lastly is the serimetric titration. Serimetric titration is a volumetric analysis method that is used to determine the stoichiometry levels of oxidation or decrease of iron 3 ions. It uses penetrolene complex as their indicator. Now let's look further into the experiment that we have chose, which is the titration of potassium permanganate with more salt and oxalic acid through this animation video. Aziza, I wonder what exactly the application of potassium permanganate, oxalic acid and more salt is. Can you explain the uses of these according to the field you know about?
Shini, don't worry, let me explain. Redox reaction can be simple, such as the burning of carbon in oxygen to produce carbon dioxide, or they can be complex, including the oxidation of glucose through a series of electron transfer processes in the human body. In daily life, potassium permanganate has great stain fighting properties and works particularly well at removing certain kind of stains like tannins and other organic substances, as well as iron and manganese stains.
In fact, more salt is used in research laboratories and educational settings to illustrate different titration methods and concepts in analytical and chemical chemistry.
Yes, Shini, you are right. Now, let's move on to application in metallurgy. Overabundant iron and manganese ions are eliminated from mine drainage water by treating it with potassium permanganate. Oxalic acid is a depressant that can be used in mineral flotation operations to prevent some minerals from floating while encouraging the flotation of other minerals. Did you know the application in the field of pharmacy, Shini?
Yes, I know. Potassium permanganate is an oxidizing agent with bacterial characteristics. It is used in the formulation of antiseptic solutions and soaks for the treatment of various skin-related conditions such as fungal infections, eczema, and other skin disorders.
In quality control laboratories for pharmaceutical, more salt can serve as a benchmark. It contributes in confirming the precision and accuracy of titration techniques applied to pharmaceutical products analysis. Next, I will explain about the application in industry. Water treatment is one of the main industrial uses for potassium permanganate. It is employed to purge water sources of contaminants, organic materials, and microbes.
In the textile industries, color dyeing procedures apply oxalic acid as a mordant. It ensures that the dyes stay on the cloth and helps fix them to fabrics and enhancing color fastness.
Also, more salt is a non-toxic and can be used as a food additive. It helps to prevent the growth of bacteria and fungi and can extend the shelf life of food. Lastly, in oral irrigation solution, potassium permanganate can function as an antibacterial agent, while oxalic acid has the ability to remove stain and bleach mildly.
Wow, the application of this material amazes me a lot, and it's actually quite around to us. So let's move on to the conclusion.
Redox titration is a laboratory technique used to determine the concentration of unknown analytes by causing a redox reaction between a titrant and an analyte. This process is categorized by reduction and oxidation, with the oxidizing agents reduced form and the reducing agents oxidized form. The titration curves form is crucial for assessing redox titrations, which are used in various fields such as chemistry, metallurgy, pharmacy, industry, food science, public health, and environmental analysis. Redox titration is nearing its practical application, but the methodology remains unclear.